Okay, I wanted to work a few more 9.6 problems involving the natural logarithm, and so here's one of them. As you can see, this is the natural log of x is equal to 1. What I like to do with these problems is rewrite without the natural logarithm notation here. I like to go to the more concrete way of writing it. Log to the base e of x is equal to 1. And I do that because my next move I need to see the base, and simply this is quicker to the point that way. Now, a quick word about this new number for you perhaps, e. Essentially this is probably the second most rich number in mathematics. It's honors Euler, which is actually spelled E-U-L-E-R, a great mathematician. So they used his first letter for this irrational number. It's irrational like pi in that it never ends, and you might be able to say pi is equal to 3.1415 and so forth. You might have the first several digits of pi memorized, but chances are you don't have the first few digits of e memorized. I don't either. I know 2.718 is about as deep as I go, and that's to the thousandths. But keep in mind that this is non-repeating and non-ending, and so we are going to have that as our base. And if you want to, you can search the web for more on this fascinating number. A rich mathematical history. However, having rewritten this problem like this, I can now translate it into exponential notation. And if you read some of my stuff online, you know that I have a technique for that. I ask you to realize that the base doesn't change positions. The base of the logarithm is going to be the base for the exponents. What changes here are the locations of these two other numbers. They switch sides. The 1 goes from the right hand side of the equal sign to the left hand side, and the x goes from the left hand side to the right hand side of the equation. And so there is my translation and my little rule for rewriting logarithms as exponential equations. Now, e to the first is simply going to be e. So there's my answer. X is equal to e. Well, the book, however, asks us to write this to the nearest thousandth. So we need to actually look at a decimal for e, and I'll bring in my calculator to do that. Let's clear this display. And so here's the key here for e, and I'll raise it to the first power. That will give me e to the first, or just e. And there you see it. Now, they want us to the nearest thousandths. So here's the thousandths position, the 8. We look to the 10,000ths position, which is 5 or less, so we're not going to upgrade the 8. And our answer here is simply going to be 2.718 to the nearest thousandth place. So there's one problem dealing with the natural logarithm. Let's take a look at another one slightly more complicated, just to get your mind right on these problems. Now, this one, 5 times the natural log of x is equal to negative 15. If I had 5 times a is equal to negative 15, you wouldn't blink or think. You'd immediately divide both sides by 5 to isolate the a. Well, the same thing here. Basically, I have 5 times the natural log, and to isolate it, I am going to divide both sides by 5. Now the 5's cancel here, and I'm left with the natural log of x, which I'll write in more detail like this, more conventionally like this. Log e to the base of x is equal to negative 3. Now, again, I'm going to rewrite. The base stays the same. The two numbers switch sides. The negative 3 comes over here. The x goes over there. And I can rewrite this as a positive exponent like this. Now, either one of these would be okay answers. This is probably more suitable for what we've been doing in Math 122. But again, the problem asks us to find the answer to the nearest thousandth. So let me drag the calculator in here and show you how I did that. Basically, I want to raise e to the negative 3, so I key in 3. I change its polarity from positive 3 to negative 3, and now I I'm ready for this key. And there's the answer. Now, I wanted to talk about this because maybe that answer is not something you know how to interpret. And I've already written it down here. Let me bring it up. There you go. That's what my calculator showed us. And essentially this part right here, think of this as multiplication by 10 to the negative 2 power. This translates that way. It's multiplication by 10 to the negative 2 power. And what we're talking about here is essentially scientific notation. This number is written in scientific notation, which was section 1.8 of our textbook. And if you remember, the constructors of our course skipped that section. Okay, multiplication by 10 to the negative 2 is the same as multiplication by 1 over 10 squared, which is actually 2 divisions by 10. So 2 divisions by 10 are going to move this 2 places to the left, and I'm going to have 0.04978 and so on. I only need to round this to the nearest thousandth, so we look to the 10,000th place. Since it's 5 or greater, I'm going to upgrade 9. I'm going to raise it a tick, and it's going to become a 10 with a carry into the 100th place. So this gets rounded up, this gets rounded up by 1, and there is our answer rounded to the nearest thousandth place. Okay, I hope that helped. The two keys were, one, having something like this. I rewrote it in more conventional logarithms with a base, and then I did the translation to exponential notation. The base stays the same and the two numbers switch sides. That's the key move for chapter 9. Okay, I hope this helps. Catch you guys later.